Hi, we have a pre-calc problem here on series, and here's what we're asked to do. Using sum notation, write an expression for the sum of every other even number starting with 2. So what we want to do is start by listing some of the first few terms of this series. We know we're starting with 2, and we're dealing with even numbers. However, be careful. It's every other even number. So we're not going to do 4 next. We're going to skip right to 6. After that, it won't be 8, but 10, 14, and so on. So when we have such a problem, we want to figure out what's going on. One big thing about math problems is to look for patterns. Patterns are huge in math. Once you can identify them, usually they would help you, they will save you time. And we see the pattern here is we keep adding 4 because we're skipping every other even number. So we're not adding 2 or 4. So now that we have the first few terms here, we first look at the common difference, which is 4, because we're skipping every other even number. So that common difference tells us it's a huge part of the sum notation we're going to write. We're going to start with 1, but we don't always have to, as we're going to see later on. We're going all the way to infinity because obviously the series never ends. So the 4 I mentioned about playing an important role, it's going to be the coefficient of the index because we're adding 4 to each term. So when I is 1 for our first index, we have 4 times 1, which gives 4. But our first term is a 2, not a 4. So we need to figure out what to do with 4. What do I subtract from 4 to get 2? That's obviously 2. So let's see, for the first term, that's saying 4 times 1 minus 2. 2. Does it work for the second term? Let's see. 4 times 2 is 8. Subtract 2, you get 6. It does. 4 times 3, 12. Subtract 2, 10. 4 times 4, 16, subtract 2, 14, and so on. So this is always going to work. However, I just mentioned earlier that we don't always have to start with 1. Another way to write this. I equals 0. What if I started with that? To infinity. Well, if I did the same, obviously we're always going to start with the 4 as our coefficient. So if I had my 4 times I, 4 times 0 is 0. But we're not starting with 0 because our first term has to be 2. So what do I have to add to 0 to get 2? To 2 I add to it. So let's see. It works for the first. 0 plus 2. How about the 6? 4, we've already used 0, so we're going to move on to 1 now. I equals 1. So 4 times 1 is 4. Add 2, you get 6. It does work. 4 times 2 is 8. Add 2, you get 10. 4 times 3 is 12. Add 2, you get 14. So this always works. The only thing is I would suggest using your I as 1. It's a little bit easier. Try to use it if possible. And the only reason for that is because when your I is 1, it corresponds to the term, the index of the term, its placement. So in this case, when I is 1, we get 4 times 1, 4 minus 2, 2. And it's a little easier to keep track of rather than I being 0. Basically, there's no such thing as a 0th term, but you have a first term. So it's always easier when your I is a 1 because that corresponds to the natural numbers. And it's easier to just keep track of what term you're dealing with. But you don't have to stick with it if you don't want to. That's it. So those are 2 ways of writing this sum notation. Thanks a lot for watching. Take care. Hope you learned something.